Good morning. My name is Utkarsh Opalkar and I will be continuing with the presentation. The work breakdown structure can be very well explained by three levels or three modules of our web semantic caching. The first level is where query results are searched for in the local cache of the client itself. If it is found, well and good. If not, we move on to the second level, where the query is passed on to the local caches of all other clients in the system. If the result is found there, it is passed back to the original client. If not, we move on to the third level, where the query is passed on to the server, where and the server will process this query and generate a result. This result is passed back to the original client, where it will get stored as well as get displayed as an output. Basically, we identified three functional requirements for semantic caching. The first one is where the system is required to pool all the cache memory together. This pooling is not physical. It's just a conceptual pooling so as to help speed up the process of finding the results for queries quicker when a client needs to search other clients' cache memories. So in that case, we need to virtually pool the caches together. Secondly, it should utilize partial data from cache memory of local clients wherever it finds the result for the query, partial result for the query. Thirdly, we should be able to intelligently combine these two partial halves and generate a desired result or an output for the user, for the client. The non-functional requirements can be broadly categorized into, can be put into three categories. Under safety requirements, we need to authorize the access of the system by the clients. So we must provide them with user IDs and passwords to ensure only the right people are accessing the system. We should also ensure data concurrency because there will be a huge number of clients and we want uh, concurrent sharing of resources. Plus, no deadlock should arise. That should also be ensured by our system. Moving on to security requirements, our system should not be vulnerable to viruses, spywares, malwares, or hackers. So it should be very secure that in that respect. Thirdly, there are no hardware requirements as we mentioned earlier under feasibility, which is a huge bonus point for our semantic caching model. Software is just a piece of code that we need to attach on the server client system, and we are ready to use this product. The use case diagram very well explains the stakeholders in our product. The most important beneficiaries are the clients. In our use case diagram, we have considered three clients. There can be many more. We have considered three. Each client may have subclients that indirectly depend on this system for their data. So each client has their own local cache. Each All of these caches are connected virtually on this fictional, you can say fictional network because it's not real. It's just I'm just using it to explain the concept better. Then on the server side, we of course have the server itself and the server administrator who ensures the smooth running of the server. Database and metadata are taken care of by the database administrator. Moving on to the functions, we have database access. All these clients would like to access the database for sure, for their query processing and other needs, which is taken care of by database access. Server time ensures that each of these clients gets some processing time on the server. This is called a time slice. Since all these caches are connected on this virtual network, we can say that this function, cache sharing function, takes care of connecting and sharing all the caches of all clients with one another. Cache searching allows users to search these shared caches. Let's say client 1 can search for the result of his query in client three's cache as well. This is ensured by cache sharing. Finally, and most importantly, query processing is a function that takes place between the clients and the server. The server processes any queries whose results have not been successfully found yet. They are passed on to the server. Server processes them, generates a result, and passes it back to the client. The client not only gets to like the result is not only displayed to the client, it is also saved to its local cache for future reference, which is why it is an incremental model. Moving on to the conclusions, we can say that semantic caching is highly useful in today's market as all major web-based systems are directly or indirectly based on server client systems. That is like, for example, even e-commerce, web, internet banking, everything is a server client system with huge number of clients. Secondly, an ever-growing client-side population indicates the necessity to reduce processing load on the server. So every day we see that a huge number of people are signing up on new websites. User base of new web-based services is growing largely, and we need to reduce the load on the server because server capacity is remaining the same. Finally, the cost effectiveness and incremental model of our product makes it very efficient and very prominent. It will never run out of uh, out of date. It will always be up to date because of the incremental model and the growing size of the local cache, and it will always be up to date. So these are our references.